Hello everyone. This video will show how to determine the y component of one of the two vectors that makes up a parallelogram. Now let's go over this example. So pretty much in this example right here, we're given vector u. So I'm going to go ahead and write that up here. So vector u has a component of 3, 0. And we also have a vector v. The x component is 2 and the y component is unknown. So I'm going to go ahead and write that up here. In this problem as well, we are given that the area formed by these two vectors is 6 units. So our task is to figure out what is the value for y. If we take the components of vector u as a and b, and the components of vector v as c and d, we can go ahead and write the formula for the area using the determinant of the matrix as. This notation right here means that the area of a parallelogram is equal to the absolute value of determinant of the matrix formed from the components of the vectors. Now let's sketch this parallelogram up here. So our u vector is 3, 0. So if this was our starting point, we go 3 to the right and we're not going up. So 1, 2, 3. So this is our first side. Our second side is 2. That means from here we go 2 steps to the right. And we don't know where do we go from here. Do we go up y unit or we go y down unit? And that's what we're trying to figure out. So let's go ahead and plug in the values that we know from here. Our area is 6. Our A is 3. Our B is 0. Our C is 2. And our D is y. So we go ahead and find the determinant for this given matrix right here. To do this, we are just going to determine the product of their diagonals. So 3 times y. Again, this is absolute value. So 3 times y minus the anti-diagonal 0 times 2. And that's absolute value. So we go ahead and do the math here. So we're able to come up with 6 is equal to 3y. Since this is absolute value, we go ahead and have 2 equations. So I'm going to go ahead and break this down into 2 equations. So these are the 2 equations that we need to use so that we can solve for y. So let's start with the first one. To solve for y, we're going to go ahead and divide both sides by 3. Our y value is 2. This tells us that vector v will have a component of 2, 2. This tells us that from here, we go 2 to the right, and we go 2 up. So we can go ahead and draw the parallelogram from here. So this parallelogram right here is formed by vector u and vector v, and the area for this is 6. Now let's solve for the other y using the other equation. So we're going to go ahead and divide both sides by 3 and solve for y. So the second value for y is -2. This tells us that vector v has a component of 2 and -2. So that we can go ahead and sketch the other parallelogram. So our u is 3, 0. So from here, I go 3 to the right. And then from here, it says that this is +2, -2. So I go 2 steps to the right and down 2 because that's negative. So 1, 2. So this is where it's going to sit. So this is vector v. So we can go ahead and sketch the parallelogram. So this blue parallelogram right here will have an area of 6. So these are the 2 possible values of y such that we are able to form a parallelogram with area of 6 square units. So that is how we solve a missing value of y component on one of the vectors that forms a parallelogram.